Hi, I'm Pete.
I'm Jacob.
I'm Charles.
And today we're going to do some absorption testing on these material samples that you see here with this impedance tube. To do it, we're going to use a program from SimCenter Test Lab called Sound Absorption Testing using Impedance Tubes. So I'm firing that up. And the program is started automatically with a new project called Project 1. Just like Word or PowerPoint, if I want to save this, I should do a file save as, and I can give it a name. And one of the first things we do is set up the channels to do measuring. We got two channels here because an absorption test requires two microphones. We got microphone A, which is closest to the speaker in the tube, and we got microphone B, which is a little farther from the speaker. And these microphones happen to be ICP, so I will set the channel mode here to ICP, and now we'll calibrate the mics. So I go into calibration here, and I want pascals. And what frequency are we calibrating at here?
94 dB, 1 kilohertz.
All right, and we got 94 dB, 1000 hertz. I can actually set it up to do both and tell it under advanced here to automatically keep looking till both are calibrated by turning the timeout off. And we got one of our microphones fully inserted into the calibrator. And I'll hit start, and it'll start looking for the calibration signal. It's calibrating mic A right now. All right, and that's done. And now we can swap in microphone B. And it's automatically detecting that too because I had turned the timeout off. All right, and we have both of our microphones calibrated. I'm going to hit accept, and then we'll jump over to absorption in tube here, now that the microphones are done. And the first step in doing the absorption measurement is to make sure we have the right tube selected. In this case, we've set up for a low frequency measurement. We're actually using the microphones that are farthest apart, position-wise, to measure the lowest. And it automatically puts in the dimensions for our tube here. After we have our tube dimensions entered correctly, the next step is to do a phase calibration between the mics. So first we're going to measure a transfer function between the two microphones. What termination do I have on the tube right now, Jacob?
Anechoic termination.
All right, so we got our anechoic termination. And measuring the transfer function between these. And then the next step is we want to reverse the microphone positions and measure the transfer function again. Now, when you put those microphones in and out, Jacob, what are you actually doing there? You got a black collet around the microphone, right?
Yeah.
Can we see that a little bit closer here? And that black collet, you're going to put the microphone all the way down till it doesn't go any further. And then you put the collet down and tighten it?
Yes.
Okay. So we want the microphone to go down as far as it can. It'll hit the tube top and should be aligned with the top of the tube. And then we tighten it in place with the collet after inserting it. All right, and now we'll measure the second one. And by the way, we had to make sure our amp here was on. So to make sure it produced the signal, otherwise our levels might be pretty low. And now we've done two measurements of the phase cal. We can calculate the phase cal, and now we're ready. And we need to reverse the microphones back to their original position. And I can go to the measure worksheet. In this measure worksheet, normally it's set up to measure several different samples of the same type of sample, and you can average them together. But I think today we're going to measure different things and kind of use it to display and overlay the measurements. To do this type of measurement, what do we normally use? Do we use the anechoic termination, Jacob?
No, we will be using the rigid termination.
All right, and you didn't put a sample in. So with a rigid termination, how much absorption do we expect to see if I was to hit measure here?
There should be no absorption.
No absorption. So I'll type in empty here, and we expect no absorption to happen, huh? Measurements in progress. At the top I have the FRF that was measured. The coherence for that FRF tells me something about its repeatability. And down here we have a very ugly looking absorption curve. But of course, absorption you should normally be looking at on a scale of 0 to 1, where 1 means all sound is absorbed, 0 means no sound is absorbed. And we can see that very little sound is being absorbed in this case. So it's very close to the bottom. All right. So now we're ready to maybe actually measure a sample for fun. Which sample are we going to measure?
We can start with measuring the white sample.
And then what do you do with that sample when you put it in?
So
you got a plunger there that moves the rigid termination back and forth.
Pull it back.
Yeah.
And you insert the sample.
And then move that plunger back in till the sample's flush at the interface. Then connect it up to the other end of the tube. So that was the white one?
Yes.
So we'll do white, measure. And now let's see how much absorption we got. Wow, quite a bit. I'll make that a little bit thicker so I can see that absorption. And if I was to put a cursor on, looks like the absorption gets up to 26% here, 50%. What if I wanted more absorption? I mean, I can get as high as absorption of 1, right?
Yeah.
So to get more absorption, I'd have to do what?
We could add another sample in.
All right, let's try that. And now we got 2 samples in there because we're trying to increase the absorption. All right, so it looks like the 2 sample did a much bigger and better job than the 1 sample, and we got the absorption now up to at least 79%. What if we tested the anechoic termination? What kind of absorption would we expect?
Theoretically, we would want to see 100% absorption.
Well, let's see if we get close to 100%. I'm on pins and needles. Whoa, that's a lot of absorption. So it looks like if I look at this thick red curve up here, we got 1 for a lot of the frequency range. It diminishes a little bit at the low frequencies because it would have to be even thicker. But yeah, that anechoic termination, it's like the bounty picker-upper of sound, absorbs it all. Cool. Thanks, Charles. Thanks, Jacob.
You're welcome. You're welcome.